Okay, this video goes with section 5.3 part 2 in your textbook. This is solving polynomial equations. Alright, so goals for this section. The two concepts are using graphing to find real roots. Alright, and remember, real roots we said was another word for like solutions or zeros. Okay, so it's still solving for x. But we're using a graphing calculator just to look for the real solutions, not the imaginary ones or complex numbers or anything like that. And then write equations from word problems, and then also solve those using graphing. Right, so a lot of times with equations from word problems, we're just interested in a real answer, like somebody's age or a distance, a length, something like that. So we kind of ignore those imaginary solutions, and then it's easier to just quickly get an answer from a graphing calculator rather than trying to factor or use the quadratic formula or something like that. Okay, so this is problem 3 in the textbook. What are the real solutions of the equation x cubed plus 5 equals 4x squared plus x? Alright, so if you used, we'll use that graphing calculator Desmos. If you plugged this in right now and tried to graph this, it's just going to show up as an error, and the reason is that right now it's only one variable, just an x, and graphing calculators only show relationships between two variables, x and y. So we need to sort of rewrite this so that the graphing calculator will recognize and graph this. Alright, so what we can do is graph each side of the equation as y equals, okay, so y equals the left, x cubed plus 5, and y equals 4x squared plus x. All right, and then you may remember, if you remember substitution, right, solving by substitution. And what we did is in an equation, you can substitute something that's equal to a variable in place of that variable. Right, so in these two equations, since they're both equal to y, now for example, right, the second one is saying y is the same thing as 4x squared plus x. So that means that in the first equation I could replace the y with 4x squared plus x. And then notice what I would have is just the original equation. All right, this one up here. All right, so what we want to do is look at the graph of these two equations and then just pretend we're solving by substitution, right? And look at the place where the two graphs intersect, because where the graphs cross each other, right, any points like that would be points where we had said, okay, well, these y's are equal, so we can just substitute in this other piece of the equation. All right, so basically you're graphing the left-hand side, graphing the right-hand side, and then looking at where they intersect, and that's going to be where the two sides are equal to each other. All right, so here it is, and I've graphed these two, okay, and then found the intersection points, and here's a slightly wider version of the graph. Okay, so now we're only interested in actually one part of these 2 points. Okay, we just care about the x coordinates. All right, so remember y, we kind of built that into the equation just so that we could find an intersection point, but when we were trying to solve, okay, what are the real solutions of this equation, we want values for x because that's the variable in the equation. Okay, so there are two solutions, and these are rounded, these are approximate. So the approximate solutions are x equals negative 1.094 and x equals 1.163. Okay, and that's all you have to do. Now remember, this is a cubic equation. It's got x cubed, so there should be at most 3 solutions, right? So keep in mind that in this case, we probably have one of these as like a double zero. Could be a multiplicity of 2 in the solution, so that's why we're not seeing all of them. Another option would be maybe we have some imaginary solutions, but you'll learn a little bit later on. Those always come in pairs, so in this case we probably have one of these that's a repeat solution. Okay, got it. Number 3 on the same page as problem 3 is what are the real solutions of the equation x cubed plus x squared equals x minus 1. Alright, so same thing, you just want to graph these two. Okay, graph the y equals the left-hand side and y equals the right-hand side. And then we'll just look at where those intersect. Alright, so here we are. And these actually intersect only in one place. And then the left-hand side, this green part, okay, keeps going up. And the other, the right-hand side of the equation continues on, but they're never going to intersect again up there. Alright, and then same thing here, this is going to continue on this direction, and this curves down, so we know based on the end behavior, like how many curves this thing has, that this is the shape, right? So it's not gonna, we know it's not gonna like loop back up or something and hit this one. Okay, so the only place where those two intersect is this point, and so then that means that there is one approximate real solution, and that's x equals negative 1.839. Alright, now there should be 3 solutions since it's an x cubed equation, so that means that the other two are imaginary solutions. Alright, and we don't need to find those since the problem just asked us to find the real solutions, so this would be your one answer. Alright, the second concept in this section is writing equations from word problems, and then same thing going on to graph them to find the real solutions. So here's an example. Stacy, Una, and Amir are close friends. Stacy is 1 year younger than Una. Amir is 2 years older than Una. If the product of their ages is 2,300 more than the sum of their ages, how old is each person? Okay, so first of all, what are we supposed to find? Okay, and if you look at the end here, we're trying to find the ages of these 3 friends. Alright, so what we want to do is write an equation with just a single variable. So equation with just maybe like an x, right, and then be able to solve. Now we actually have 3 unknowns here. We don't know any of their ages, Stacy, Una, or Amir. So what we need to do is we'll call the age of one of them x, and then we'll write the ages of the other 2 in comparison to the one that we've called x. All right, so first sentence, just kind of background information, we don't really need that. The next 2 sentences are important, all right, and notice that they are describing Stacy and Amir's ages in terms of Una's. So Una's is kind of like that unifying factor. So let's call Una's age x. So x equals Una's age. Okay. Now if we wanted to talk about Stacy's age, Stacy is a year younger than Una. Right? So like if Una was 9, Stacy would be 8. Okay. Well, how do we describe that relationship? Right? Well, if x is 9, because x is Una's age, then we'd need to subtract 1 from that to get Stacy's age. Alright, so x minus 1, 1 year less than Una's age, that's Stacy's age. Alright, and then how about Amir? Amir is 2 years older than Una. Okay, so 2 years older, whatever Una is, if you add 2 to that, that would be Amir's age. Alright, and you can try it out with some numbers, just like we did with Una and Stacy to make sure. Alright, so if Una is, I think we said 9 before. Okay, well then 9 plus 2 is 11. Alright, and then just see if that fits the problem. 9 and 11 for Una and Amir, that is 2 years older. Alright, Amir is 2 years older. Okay, so we have these 3 expressions for their ages. And now we need to go on and write an equation using those. right, so this last sentence tells you how to put everything together. The product of their ages is 2,300 more than the sum of their ages. All right, just a quick review, the word is usually indicates an equal sign. So we're going to start with that and then try to build the two halves of the equation. All right, so in front of the is, we have the product of their ages. Okay, product and sum are two words that you need to remember what that means mathematically. And product means multiplication. So this is saying if you multiply all of their ages together, that's 2,300 more than the sum of their ages. Okay, so the product of their ages would be x times x minus 1. And since I have two terms here, I can't just put a multiplication sign in the middle. That would mean x times x, but it wouldn't mean x times this negative 1. All right, so instead what I need to do is put these all in parentheses. Okay, so anytime there's more than one term that you're multiplying, put it in parentheses. All right, and then Amir's age, so times x plus 2. All right, so that's the product of their ages. Then the sum of their ages, so the product is 2,300 more than the sum. Okay, so more than means adding. So we would need to add 2,300 to the smaller sum in order to get this bigger product. Okay, so the product is 2,300 more than the sum of their ages. So we would add all the ages together, x plus x minus 1 plus x minus 2. If it had been the difference, then I would need to put these in parentheses. Okay, but for addition, it doesn't really matter, so you can just leave out the parentheses. Okay, so the next thing I need to do is simplify this. I need to actually find, okay, the product and the sum. Minus 1, x plus 2. Oops. Plus, okay, and then add all of these up. Alright, so on the left-hand side, first thing I would do is probably distribute. You can multiply these in any order, but I'll usually take care of any like little distributing single term things first. Alright, so x times x minus 1 would be x squared minus x. Okay, don't forget to put that in parentheses. Times x plus 2. And now this is a foiling problem. Alright, so x squared times x is x cubed. Okay, that's firsts, and then we have outer, so that would be x squared times 2, which would be plus 2x. Okay, and then inner would be negative x times positive x minus x squared. And then last would be negative x times 2, or minus 2x. Okay. And let's see, I think this should be an x squared, right? The outer 2 times x squared, 2x squared. Thought that looked a little funny. Okay, so that's foiled. Then we need to combine like terms. So this would be x cubed. And then we've got the x squareds that can be combined, so that 2x squared minus x squared is plus x squared minus 2x. All right, and then on the right, we just need to combine all the like terms. So we have x, x, and x, that's 3x. And then the numbers, we have 2,300 minus 1 and plus 2. Okay, so if you do 2 and minus 1 first, that's a plus 1. And then 2,300 plus 1 is plus 2,301. Okay, so now we have an equation, and we need to solve this for x. We're trying to solve for their ages, so we definitely are just interested in the real answer, not anything that's an imaginary number. So one option is what we've already been doing, which is to graph each of these. Okay, set them equal to y. Let me give you one other option, just in case you see this in your textbook or in maybe future textbooks. Another thing you can do is move everything to one side and set it equal to 0. So I'm going to do that by combining like terms. X cubed plus x squared. And now I'm going to subtract 3x and move that over. So I end up with negative 5x. Right, and then subtract 2300 and 1 and move that over. And then that's equal to 0. Okay, so now same thing, if I go to graph this, I can graph the left-hand side, y equals the left, and then you could graph the right-hand side, y equals 0, or you could just get used to seeing, all right, if you did graph that, that's just going to be this axis right here. This is the line y equals 0. All right, so what we're doing is just looking for where the left-hand side of the equation equals 0, where it crosses the line that represents 0. Okay, and so here it is. So you can graph that if you want to, or you can just look at where it crosses the axis. And it crosses at the point 13, 0. Okay, and our original equation only had x's in it, so that's the one we're interested in. We just wanted to know what x was. And here we actually have an exact answer, x equals 13. So now since this is a word problem, there's one more step. You take it back to the problem and just try to answer the question, how old is each person? Well, x equals 13, well that's Una's age. Okay, and then Stacy's age is 13 minus 1, so she's 12. And then Amir is 13 plus 2, she's 15. Okay, so to review, our goal to try to write an equation with just one variable in it. If you have more than one thing that's unknown, then you try to write everything just in terms of one variable. Okay, so that's the part where we had x. And then instead of calling Stacy and Amir like y and z or something like that, instead we described them in terms of Una's age. Okay, write your equation. You may need to simplify a little bit by doing some multiplying, okay, moving stuff around, and then ultimately you're going to graph and try to find the real answer. Okay, here's another one. What are the 3 consecutive integers whose product is 480 more than their sum? Okay, so here's the question. What are 3 consecutive integers? Remember that consecutive means right in a row, one after the other. Okay, integers are your number line numbers, so like -5, -4. Okay, if we kind of made a number line here. Dot, 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 okay, and then continuing on. So 3 consecutive integers can be positive, negative, or 0, and they have to be consecutive. So in other words, like 1, 2, 3 are 3 consecutive integers. These 3 are consecutive integers. All right. And then we need their product. This part's going to be your equation. Their product is 480 more than their sum. Right, so first of all, we need to figure out what x is, and then write some things in terms of that. All right, so let's just call one of the integers x. Maybe we'll call it the first one. Okay, so x represents the first integer in this consecutive sequence. Okay, well then what would the next one be? All right, so think of our sample numbers like 1, 2, and 3. If x represents 1, well, how can I describe 2 in terms of that? Well, notice it's just 1 more than that. So x plus 1 would be the second consecutive integer. Okay, and then how about the 3? All right, well, it's 1 more than 2, and it's 2 more than 1. Okay, so this would be actually x plus 2. All right, so that's the third integer. Okay, then to write the equation, their product is 480 more than their sum. Okay, product, multiply. So same as the last one, you want to write the product of these all in parentheses. Is the clue that means an equal sign. Okay, 480 more than their sum. So we've got to add 480 to the sum, and the sum is just adding them all up. X plus 1 plus x plus 2. Okay, and then do some simplifying. Okay, so I'll distribute the x. Okay, this would be x times x is x squared, and then x times 1 is plus x. And then I need to do times x plus 2. Now remember, you can't write it like this. This needs to be in parentheses. If it's not, then that means, if you just left it like this, that means x distributed to each of these, and then add the x squared after that, but we want to show that it's the whole thing still being multiplied. Okay, so put parentheses around that. Then on the right, combining like terms, we have 3x's, and then we have 480 plus 1 plus 2, and that's 483. Okay. Now, you actually really don't even need to multiply this. All right, so there would be nothing wrong with just graphing, y equals at this step. All right, so it's good practice just to remember how to multiply. But if you wanted to, you could just now, at any point, type this in. Okay, y equals x squared plus x times x plus 2. Okay, and y equals, and then if it's some quick addition, maybe you want to do that. So maybe instead of this, maybe you want to graph 3x plus 483, and then look at where those two graphs intersect. All right, so here's the graph that I've created, and those intersect when x is 7. All right, now this line, we know by the behavior, it just kind of keeps going, and this cubic function, okay, it's just going to keep going down, and here it's going to keep going up. Right? It's cubic because it's an x squared times an x. If we were to multiply that all out, and we can see these two curves, so I know that there's no more curves. Cubics only have two curves, two turning points, so there's no way that this is going to come back down and re-hit that line or something like that. All right, so there's just one solution, and the solution is when x equals 7. Right. Now we need to finish up by backing up and answering the question. All right, what are 3 consecutive integers? So we know what x is. That's the first integer, 7. Okay, so then the others would just be 8 and 9. All right. Now this one we actually could check. Their product should be 480 more than their sum. All right, so multiply those 3 together and then add them and then see if the product is 480 more than their sum. Okay, so try it out. Do 7 times 8 times 9, and then add them. Okay, and then see if this one, the product, is 480 bigger than this sum. All right, so I'll leave that for you to check. I wanted to do one more with you that's a geometry one, and then I'm going to give you a second geometry one as a homework question. Okay, so we'll do number 25, and these are the exercises in your book with this section. This is page 317. Okay, the width of a plastic storage box is 1 foot longer than the height. The length is 4 feet longer than the height. The volume is 36 feet cubed. What are the dimensions of the box? Okay, so here are some steps, and you can kind of think through these with the next question as well. What is the formula for the volume of a rectangular prism? Or in other words, a box shape that's rectangular. Okay, so here it would be okay, so kind of a box shape like this, that's a rectangular prism. All right, and these have a length to them and a width. Those are the dimensions of the base of the box. And then for height, we usually consider like the up and down dimension, how tall the box is to be the height. All right, while volume, okay, you might remember to find the volume of a box, you just do length times width times height. All right, so this is going to be the big equation that we're going to use for this problem. All right, now we need to just fill in all of the variables and things that we know. Okay, so next, what variable expressions represent length, height, and width? Okay, so we're just going to fill in everything we know. We're supposed to be solving for the dimensions of the box. Right? In other words, we need to know what is the length, what is the width, and what is the height? Okay, so we know that the width is 1 foot longer than the height, and the length is 4 feet longer than the height. So notice everything's being compared to height, so we're going to have height be the variable. Okay, so I'm going to relabel this and call this x. Okay, and then I'm going to write the other two dimensions in terms of that height. So the width is 1 foot longer than the height, so the width is x plus 1. Okay, and then the length is 4 feet longer than the height, so plus 4. All right, so I know length, I know width, I know height, and then volume, we're actually given the volume, we're given the number. So that's what I'm going to plug in for volume. All right, so next to write the equation, I'm just going to make some substitutions. So I'll write 36 instead of volume. Instead of length, I'm going to write x plus 4. All right, now these are all being multiplied. So times the width, which is x plus 1, and times the height, which is x. Okay? So now to solve, we can graph. And again, you have multiple options here. You could multiply these all out and graph that. We could move everything to one side and make a graph, see where it crosses 0. All right. In this case, I could also graph y equals 36, and then y equals all this stuff on the right, and see where those two things cross. Okay, because all of this represents volume, and I would like to know where it equals or crosses 36. Okay, so here's my graph. The other thing to notice, there's nothing wrong with moving these expressions around when you go to graph. All right, so we had x plus 4 first, and then x plus 1, and I've moved the x to the front, so it doesn't really matter with multiplication. Okay, remember you can multiply in any order, that's the commutative property. Alright, so we're looking for where these cross, where that intersects with 36, and here it is, right? And the point is when x equals 2. Now y equals 36, that's a flat line, and this function just continues going down and going up, so again, that's not going to cross at any other spot than this exact spot. Okay, so again, we're only interested in the x value, x equals 2. So then go back to the problem here. And then to find the dimensions of the box, we're just going to make some substitutions. Okay, so the height of the box, that's the one that was x. So the height is 2. And I need to put some units on this. Okay, so these aren't just integers, they represent dimensions. Everything here is in terms of feet, so that would be a feet. Okay, then x plus 1, that's the width. Alright, so width was x plus 2. Oh, x plus 1. So the width is 3 feet. Okay, and then the length, okay, that's this x plus 4. So that would be 2 plus 4, and that would be 6 feet. Okay, so if they asked for the dimensions of the box, here are your answers, 2, 3, and 6 feet. Okay, and then a check for this one, we could just substitute back into the volume formula. So just multiply 2 times 3 times 6 and make sure that that does equal the given volume, which was supposed to be 36 feet cubed. Okay, and 2 times 3 times 6 is 36, so that works. Alright, you have another one here, another geometry homework problem to try. Same idea here with writing expressions for width, height, and length. And maybe the expressions will just look a little bit different, but you're still given a volume, and you can still graph and solve the same way. Alright, so here's your homework assignment, pages 316 and 317. The first set, 7, 9, 11, 12, these are just finding the real solutions by graphing. And then 16, 17, and 26 are word problems. So make sure you go all the way to the point where you can answer the question, give it some units, like years or feet or something like that, okay, if needed. And then number 16, this is one of those ones where they've started the problem for you and helped you think about how you would set up an equation, but they didn't actually finish the problem. So this is an age question. How old are the twins? So keep going until you can actually answer with their age. All right, I hope that's helpful for you. Text me if you have any questions. Okay, thanks. Bye.